factor theorem of polynomials. The factoring theorem states for any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. So if we want to say if it is a factor or not, we need to first find a given our factor and then plug it in and see if it equals 0. So the first thing we need to do is find our form x minus our a. So to make this x minus something, it would be minus 1. X minus a negative 1 makes it a positive 1 on the inside. So just as we've done before, we have to switch whatever is inside those parentheses. Switch the sign inside the parentheses. And then my original p of x function is right there. So I just need to plug it in. So if I'm finding p of a, that's going to be p of negative 1. So that's going to give me negative 1 squared minus 3 times negative 1 plus 1. So that would be negative 1 times negative 1, which is a positive 1. Negative 3 times negative 1 is a positive 3 plus 1. So 1 plus 3 plus 1 is 5. So that means p of negative 1 equals 5. Well, that does not equal 0, so it is not a factor. So that's all you have to do. You plug it in. If it does not equal 0, then you just say it's not a factor. So let's do another example here. We have to switch our inside sign because it has to be of the form x minus something, so minus a negative 2. And my p of x function is 3x to the 4th plus 6x to the 3rd minus 5x minus 10. So if I plug it in, p of a equals p of negative 2, which equals 3 times negative 2 to the 4th plus 6 times negative 2 cubed minus 5 times negative 2 minus 10. So that's going to give me 3 times 16 plus 6 times negative 8 plus 10 minus 10. If we simplify that further, it's 48 minus 48 plus 10 minus 10. So that means that our 10s cancel out and our 48s are going to cancel out, leaving me with 0. So what that means is p of negative 2 equals 0, and therefore the factor x plus 2 is a factor. And that's your final answer. Because it equals 0, it is a factor. Kind of switching gears here with this next example. If we want to factor large polynomials, sometimes we can use a grouping method. Now, we're going to actually factor this using the grouping method. Most times this is not going to be the easiest way to do it, but sometimes in very special cases it will work out. So the grouping method says that we're going to group our first terms here and our second terms, and we're going to see what we can factor out of each part. So in this first one, we can factor out an x squared. And then that would leave us with x squared on the outside and then an x minus 1. Now we want to figure out what we can factor out of the other one. If we factor out a negative 25, then that would give me negative 25, and then we'd be left with x minus 1 on the inside. Now the reason we use the grouping method here is because when we factor that out, then we have an x minus 1 and x minus 1, so we can factor out the x minus 1. So that would give us x minus 1 times x squared minus 25. Now at this point, we have to remember our difference of squares. Okay, so that's going to tell me that if we have a squared minus b squared, that's going to be equal to a minus b, a plus b. Okay, so in this case, my a is equal to x, and my b is equal to 5, because 5 squared is 25. So my final factorization would be the x minus 1, and then my a minus b, so x minus 5, and my a plus b, x plus 5. So that would be my complete factorization. Like I said, this only works with some very special types of polynomials, so it's not always going to work for you. But that is a method to use in some cases. Those are your notes over the factor theorem of polynomials. Go through the practice problems. Make sure that you understand when to use the factor theorem and why we use it, and then you can take your quiz.